In this video, I'm just going to go over three basic properties of logarithms, which will just make logarithms a little easier to work with. The first property is this: log base a of 1 is equal to 0 for any base. So this is fairly easy to prove or to see why this is true. So the proof of this, if you let x equal to log base a of 1, and then if you write in exponential form, that would be a to the power of x equals 1. And the only way that something to the power of x would be equal to 1 is if x is equal to 0, because anything to the power of 0 is 1. So therefore, log base a of 1 must be 0. Okay, so there's your proof. So here's an example of using this property. Let's say I asked you to do log base 1,000 of 1. You don't need to, normally when we were evaluating logarithms before, we would convert to exponential form, do something like that. You don't have to do that here. You can just say it's equal to 0 by this property, right? Because log base anything of 1 is always equal to 0. So that's always going to be true. Property 2. This is the property you're going to probably find the most useful. This property will help us evaluate logarithms much quicker than we did in the previous lesson. So what this one says is that log base a of a to the power of x is equal to x. And to see why this one's true, again, we'll just take the left side here. So we'll just say let the left side be equal to, let's say, y. And we're just going to show that y has to be equal to x. Then write this in exponential form. So this would be a to the power of y is equal to the input of the logarithm, which is just a to the x, but you have a to the y equals a to the x, therefore the exponents must be equal. Therefore y equals x, therefore log base a of a to the x is x. So let me show you how you're going to use this law and why it's going to be so useful for you. So if you think about the examples that we had before, or in the previous video or lesson, we were evaluating logarithms, something like this. Evaluate log, doesn't matter, let's say base 7 of 49. And what we had to do before was we had to make a let statement, let this be equal to x, convert it to exponential form, and then solve the exponential equation. I don't have to do that anymore. All I need to do is get it into this form here. I just need to get the input here, the 49, to be a to the power of something, where a is the same base here. So I need to write this log base 7, and now I want to rewrite 49 as 7 to the power of something. So 49 is 7 to the power of 2. And now notice these bases are the same, so this is your a. So this is just equal to the exponent here. So the exponent is 2, right? It's just equal to x, so the exponent is 2. So log base 7 of 49 is equal to 2. So if you can make this base and this base the same, the base of the logarithm and the base of the exponential the same, then you use this property and you don't have to convert to exponential form. Here's just another example where we'll use that same property. This one involves a square root, so maybe a little bit more complicated, but same thing. You just want to make the input 5 to the power of something. So this would be 125 to the power of a half. The square root is the power of a half. So log base 5, then 125 is 5 to the power of 3, all to the power of a half. So that'd be log base 5 of 5 to the power of 3 over 2. And now I can apply that property. This base and this base are the same, so the answer is just equal to the exponent. So that's how you can use that property number 2 to solve logarithms. And now property 3, you're not going to use this one as much, but it is useful. So what it says is, if you have an exponential a to the power of a logarithm, base a, so the same basis of x, then your answer is just going to be equal to x. And the proof of this is, again, pretty straightforward. You're just going to say let y be equal to the left side of this equation, and then show that y is equal to x. So we'll convert this to notice in this case it's already in exponential form. So we'll write in logarithmic form. So in logarithmic form this would be log base a. So base a because this is the base, and now the input of my logarithm is the output, which was y, and then that's equal to the exponent. So log base a of x. So notice I have log base a on both sides, so the input is y and the input is x, so y must be equal to x. Okay, so therefore the original thing we stated was true. A to the power of log base a of x is equal to x. And let me just give you an example of what we mean here. So basically the example would be with numbers. So let's say a 2 to the power of log base 2 of whatever, let's say it was to the power of 5, then this is just equal to 5 because this base and this base are the same. So that's the third property. Again, the second property is the one you're going to use the most, but all three properties will have their place and can be useful.